What does that mean? Now, when you charge an object to a very high electric field, now I'm going to say if you charge an object to a very high potential, that will result in dielectric breakdown of the air by producing ions in the air. That means air will become conducting, and that is how you get the shock. All right. Air is normally an insulator. A good insulator is called a dielectric. A very high electric field produces ionization in air and other dielectrics and make them conducting. And this process is called dielectric breakdown. And what is responsible for that? A very high electric field. Now, this phenomenon is what we call dielectric breakdown. Dielectric breakdown happens in air at an electric field strength. We talked about it in the last class. 3 times 10 to the 6th volt per meter. Now, that is the reason why we got lightning. You know, clouds, when clouds move in air, the rubbing of the clouds with the air molecules create large amounts of electric charges. Now, suppose we have a big old negatively charged cloud overhead. You see, when clouds move in the atmosphere, they are continuously rubbing against the air molecules. That means there will be charges created. So clouds will be full of excess charges. So suppose a big old negatively charged cloud passes overhead. Now, nearby conducting ground acquires an induced positive charge, establishing an electric field between the cloud and the earth. Now, this is the phenomenon. Here is the cloud that carries a large amount of negative charge, and this is the ground. Because of the presence of these large negative charges directly above the ground gets a lot of induced positive charge. Now that means a very high electric field is now established between the cloud and the ground. And the electric field will be like this. And now, if this electric field is above the dielectric breakdown, that is 3 times 10 to the 6th volt per meter, then the air will become a conductor and the electric charges will discharge through air to the ground. And that is what we call lightning and thunder. And that could be a pretty bad shock if you happen to be in the path. If there are high buildings or trees in the path, you know what will happen. Well, that is due to the dielectric breakdown. If the electric field exceeds the E max, that is the maximum electric field before dielectric breakdown, then dielectric breakdown occurs and a sudden burst of discharge occurs between the cloud and the earth, burning anything in its path, houses, humans, or anything. Now, this devastating effect of lightning can be prevented by using lightning arresters. Now, what is a lightning arrestor? Have you seen one of those? A lightning arrestor is an arrangement of conductors that have pointed ends. Suppose you have a building here, that's a building, very tall building. Now install on top of the building something like this, spiked conductors and connected to the ground. You know what grounding means. Now when clouds pass by near the building, where suppose there is a build of charges there, now what happens is the presence of these charges will induce positive charges on the spiked conductors. So there will be induced charges on the conductors and because of the pointed ends, all those induced charges will be concentrated at the pointed ends, and the concentration of these positive charges will gradually neutralize all the negative charges in the cloud. So what does the lightning arrest to do? It will gradually neutralize all the buildup of charges, thereby preventing a discharge. So this is a very useful thing to do for very tall buildings, and in many places in the world I have actually seen lightning conductors. I haven't seen them in Florida, although Florida is called the lightning capital of the world. Well, let me see if I can show you a simulation. Now this is a simulation of how electric charges get accumulated in the cloud, and as the accumulation happens, you can see they discharge to the earth, and if this unfortunate house happened to be in the path, well, God help us, is that right? Now it can be prevented by using a lightning conductor. If you have a lightning conductor on this building, that lightning conductor will neutralize the buildup of charges in the cloud, thereby preventing a lightning discharge. Now you can see lightning discharge occurs not only between the cloud and the earth, it also happens between clouds. If you notice, it can happen between clouds. One cloud that is positively charged, another that is negatively charged, can create electrical discharge. Well, that is a good illustration of how electric discharge occurs in nature. Let's now solve another problem. Two horizontal metal plates are separated by 10 centimeters, and an electric field between them has a magnitude of 1 times 10 to the 4 Newton per Coulomb, directed from the lower plate to the upper plate, as shown in the figure like this. What is the charge density on the upper plate? What is the charge density on the lower plate? What is the potential difference between the plates? What is the potential of the upper plate if the lower plate is grounded? A small particle of mass m and carrying a charge q is in equilibrium in the space between the charges. What is the charge carried by the object? Alright, let's look at these. The electric field between the two plates is E equal to sigma over epsilon naught. Do you remember that one? The electric field between two parallel metal plates that are charged, each will contribute a field of sigma over 2 epsilon naught. The total field will be sigma over epsilon naught. Therefore, sigma equal to E epsilon naught. That will be electric field is given to us, multiplied by sigma. That will be 8.85 times 10 to the negative 8 coulombs per meter squared is the charge density. Well, we need to find the charge density on the upper plate and at the lower plate. Tell me, the electric field is given to be directed from the lower plate to the upper plate. So, what is the charge on the upper plate? Is it positive or negative? An electric field will originate from a positive and end in a negative. So that means the lower plate is positive and the upper plate is negative. The direction of E suggests that the upper plate is negative and the lower plate is positive. That means the charge density on the upper plate has this negative value and the lower plate has the same positive value. The charge density on the upper plate is negative and the charge density on the lower plate is the same negative value. What is the potential difference between the plates? Well, do you know the relation between electric field and potential difference? The relation between E and V. is E equal to negative V over delta X. What is delta X here? Delta X is the plate separation. So delta V equal to negative E delta X, and that will be negative E is given to us, delta X, the separation of the plates, is given to us. Therefore, the potential difference is negative 1000 volt. Well, what's the next thing we need to find? The lower plate is grounded, means that the potential of the grounded is zero. Anything that is grounded is at zero potential, and therefore the potential of the upper plate is negative 1000 volt. It is a negative plate. Its potential is negative 1000 volt. Okay, how about the last part? We have an object that carries a charge Q is in equilibrium in the space. What does that mean? If the object carrying a charge has to be in equilibrium, then the weight of the object acting vertically down must be balanced by the electrical force that must be acting up. So obviously it is a positive charge, because only a positive charge experiences a force in the direction of the field. When the particle is in equilibrium, its weight mg is balanced by the electrical force. You remember, when a charge Q placed in an electric field E, the force on it is Q times E. So when a charged object is placed in the electric field, the weight mg downward is balanced by the electric field Q times E. So QE equal to mg. Therefore Q equal to mg divided by E. And now we have mass is given to us, and G we know is 9.8 meter per second squared, and E is also given to us. So that charge is 9.8 times 10 to the negative 9 coulombs. Well, that means that will be 9.8 nano coulombs. Is that right? Okay, I think I'm going to stop this lesson here. We have done now a number of illustrations on potential difference, the relation between electric field and potential, and so on. And this is the end of Unit 3. We talked about static electricity, electric charges, electric field, electric potential, which we will be using in our next unit. So it is now time for your next test. Now go through your practice test and make sure that you are ready for the test before you open it. All right? I will see you for Unit 4 a little while later.